Okay, so some of you guys might have struggled a little bit with 4-6 today. And so I want to be clear about how to do this. So let's first take a look at the word problem, right? So a plant nursery is 3 feet tall. So it starts out at 3 feet tall and then it grows 1 foot per year. So if I want to write an equation for that, that is 1 foot per year, where x is the number of years, plus 3, because it starts out as 3 feet tall. Then what I'm going to do is it starts at 4, another tree starts at 4 feet tall and it grows 1/2 foot per year. So then I have 1/2 x, but it starts at 4. And I want to know when the trees will be at the same height. So essentially what I want to do is I want to go back to the way we did it with substitution. These are both y equations. So what I'm going to do is I'm going to set them equal to each other, meaning I'm going to take what y is here and I'm going to plug it in here. So I have 1/2 x plus 4 is equal to x plus 3. So I'm going to subtract 1/2 x from both sides. And I get 4 is equal to 1/2 x plus 3. Subtract both sides by 3. And I get 1 is equal to 1/2 x. Dividing by 1/2 is the same thing as multiplying by 2 over 1. Remember, if I multiply by the reciprocal, then I can cancel out the 2's. So then I get x is equal to 2. Well, I don't, some of you guys are writing it as a coordinate point. I actually want you to answer the question. After how many years will the trees be at the same height? So after 2 years, the trees will be at the same height. Okay. So that's really what I want. I don't need the y value. I just need the number of years. Okay. Now, I know some of you guys had questions about 2. If you graph a system of equations, if a point is a solution on one of the lines, is a solution to the system. Remember what I told you when you go back and you check your answers. A system of equations, the solution to the system has to work in both equations, not just in one. Okay. So that's your answer to 2. 3, can a system of equations have exactly 2 solutions? Exactly 2. That's not the same thing as infinitely many. Exactly 2 means that they cross each other twice and only twice. 2 linear equations can only cross at once, or it can be, remember I told you, infinitely. I totally spelled that wrong. Let's take it slower. Infinitely many solutions. Okay. Suppose you have 2 linear equations. Suppose 2 linear equations are true at -2, 3. What can you conclude about the graphs of those equations? So if you have 2 linear equations that are true at this coordinate point, then that is the solution. That's where they intersect. Okay. If I look at 5, what's the error? The error is that the slopes are not the same. So for no solution, the slopes have to be equal. The slopes are not equal. So because I have both a y equals -x plus 3, and I told you in all these, I don't care how you guys solve them at this point. So because they're both y equations, I'm going to set these two, I'm going to plug this -2x minus 1 in for that y. So I have -2x minus 1 is equal to -x plus 3. So I add 2x to both sides, and I get -1 is equal to x plus 3. Subtract 3 from both sides, and I get x is equal to -4. So that's my x value. My y value is going to be -x plus 3. So y is equal to -4 plus 3. So y is equal to 7 because the 2 negatives turn into a positive. So my solution would be at -4, 7. But that is actually off the graph, and that's why it doesn't work, or that's why it looks like it doesn't intersect. Okay? And that's it for this section.